We present Chorus, Learning Canonicalized 3D Human-Object Spatial Relations, from Unbounded Synthesized Images. We present a novel method to learn generalized canonical representation of 3D human-object spatial relations. Given a category keyword of an object, our method extracts 3D human-object spatial relationship, represented as probabilistic occupancy distribution of an object. Our method returns a set of possible distributions for various types of human-object interaction, where interaction type is represented as natural language description, and optionally can be further specified with body parts. Our method returns pose-conditional distributions by learning 3D knowledge in pose-canonicalized space, allowing us to model the object distribution for any human pose. Our method builds upon the intuition that unbound synthesized 2D images contain spatial knowledge that conveys 3D spatial relationships between human and object. The key challenge then is, 1. How do we get the 2D data, and 2. How to unify 2D spatial knowledge, from unbound, wild and variant images, into single 3D space. To mitigate challenges, our method leverages generative models to generate data, and canonicalization strategies for learning 3D. Our method starts by generating text prompts that describe plausible human-object interactions. We then leverage text-to-image diffusion models to synthesize images with multiple viewpoints. Next, we apply multiple human-based canonicalization strategies to aggregate 2D cues to 3D space. Using the human-object interaction prompts generated earlier, we apply clustering to learn 3D per semantic type. Given category keyword, we generate prompts that describe plausible human-object interaction by using publicly available large language model. We then leverage text-conditional diffusion models to synthesize 2D cues. We apply keypoint-based filtering to remove unsuitable images. To disambiguate unknown camera and coordinates for synthesized images, we predict 3D humans from images, and use humans as anchor for calibration. Using disambiguated camera, we extract object segmentation as 2D spatial cues and aggregate to human-centric 3D space. However, naive aggregation of 2D cues will lead to disperse accumulation and cause high variance due to remaining pose diversity. To mitigate this issue, we aggregate cues in pose-canonicalized space to assure coherency between rays. By canonicalization we can also learn pose-conditional distribution. Using the prompts generated earlier, we can cluster the distribution, per interaction type, by simply selecting the images to aggregate. Aggregating all images from all prompts collapse semantic modes, and return marginalized distribution, for the most probable interaction type. Selecting images only generated from specified prompt gives us a distribution specific to the interaction type described in prompt. Still, there may exist ambiguity due to lack of information in the prompt. Optionally, our method further specify the interaction type using body part, and only aggregate 2D cues if specified body part involves in interaction. Our method can learn 3D human-object spatial relationship for various categories, by simply providing a keyword. Our method can effectively disentangle distributions for interaction types described in text prompts. We can further specify distribution by providing interaction body part, when given prompt does not specify the human-object interaction well, or the prompt contains ambiguity. Applying canonicalization enhances precision and reduces variation of learned distribution. Our work can be easily applied to downstream tasks, including human object reconstruction from single image. We can generate object geometry without requiring any templates. Thank you for watching.